Welcome, everyone. I'm excited to kick off today's presentation on data classification. Today's topic is all about understanding how we categorize and manage data effectively. We'll explore the different types of data, why classification matters, and how it helps in safeguarding information. So, let's get started and dive into the essentials of data classification. Data can be classified into three main categories: structured, unstructured, and semi-structured. Structured data is organized and formatted in a specific way, which makes it easy to search and analyze. Think of spreadsheets and databases. They're prime examples of structured data because everything is in a well-defined format. Unstructured data, on the other hand, isn't formatted in a specific way. It can include things like text documents, images, audio, and videos. While unstructured data can be more challenging to analyze, it often holds valuable insights into customer behavior and market trends. Examples include social media posts, customer reviews, and email messages. Then we have semi-structured data, which is a mix of both. It has some defined structure, like XML or JSON files, but also includes unstructured elements. Understanding these categories helps us better organize, analyze, and derive value from different types of data, which is key to making informed decisions in today's data-driven world. Another way to classify data is by its type, which can be either quantitative or qualitative. Quantitative data is all about numbers. It's measurable and can be analyzed statistically. Think of things like sales figures, customer counts based on different locations, or website traffic stats. These are concrete, numerical pieces of information that help us make precise decisions. On the other hand, qualitative data is non-numerical. It includes things like text, images, or videos. While it might be a bit trickier to analyze because it's not in numbers, it often provides richer insights into customer preferences and opinions. Examples include customer reviews, social media posts, or survey responses. Understanding these types helps us choose the right approach for analyzing our data, which ties into the overall goal of making smarter, data-driven decisions. Both types have their unique strengths, and knowing when to use each is key to effective data analysis. Now, let's talk about some of the key steps involved in preparing data for analysis. First, data collection is all about gathering data from a variety of sources. These sources can be anything from surveys and social media to sensors or existing databases. The goal here is to gather as much relevant data as possible to support your analysis. Next is data labeling, which involves assigning tags or labels to your data. This step makes the data much easier to search and analyze later on. For example, you might categorize data by age groups, product types, or geographical regions. Proper labeling helps you quickly identify patterns and draw meaningful insights. Then we have data cleaning. This step is about improving the quality and accuracy of your data. It involves removing duplicate entries, fixing spelling mistakes, and filling in missing information. Clean data ensures that your analysis is based on reliable, consistent information, which ultimately leads to better, more trustworthy results. All these steps, collection, labeling, and cleaning, are crucial because they set the foundation for effective data analysis. Without them, your insights might be flawed or incomplete. So, understanding and executing these steps well is essential in making your data work for you. Artificial intelligence is such an expansive field, and at its core, it's all about making machines learn and think like humans. There are many different technologies that fall under the AI umbrella, each with its own unique capabilities. For example, machine learning uses mathematical algorithms to analyze data, helping machines find patterns and make predictions. It's like giving computers the ability to learn from experience. Deep learning takes this a step further by using neural networks, which are designed to mimic how our brains process information. As the amount of data increases, deep learning becomes even more powerful and efficient at recognizing complex patterns. Natural language processing, or NLP, is another key technology. It enables machines to understand human language, whether spoken or written, and then perform actions based on that understanding. That's how virtual assistants can respond to your questions or commands. Large language models are advanced AI systems trained on enormous amounts of text data. They can understand and generate human-like text, making interactions more natural and seamless. Then there's computer vision, which allows machines to interpret visual information, like recognizing objects in images or videos. This technology is fundamental in applications like facial recognition or autonomous vehicles. Finally, robotics combines AI with physical machines, enabling them to perform tasks in the real world, whether it's assembling products, delivering packages, or assisting in healthcare. All these technologies are interconnected, and together, they form the backbone of modern AI. They're transforming industries and shaping the future, making machines smarter, more intuitive, and more capable of working alongside us. Now, let's explore the different types of machine learning. First, supervised learning. This is where the model learns from labeled data. It's like teaching a student with examples and answers. The model finds patterns in the data and then uses those patterns to make predictions or classify new, unseen data. It's really powerful when you have clear, labeled datasets. Next, we have unsupervised learning. Here, the data isn't labeled, so the model has to discover patterns on its own. It looks for similarities, groups data points that are alike, or uncovers hidden structures within the dataset. This approach is great for exploring data and finding insights without predefined answers. Finally, reinforcement learning is a bit different. Think of it like training a dog. You try actions, see what works, and learn from the outcomes. An agent interacts with an environment, takes actions, and learns to maximize rewards over time. This type of learning is often used in robotics, game playing, and autonomous systems, where making the best decision is crucial and must be learned through trial and error. All these types of learning connect to the bigger picture of how machines can mimic human intelligence and adapt to different tasks. Each approach has its strengths and is suited to different kinds of problems. Thank you for your time and attention today. I really appreciate your engagement and interest in the topic we've discussed. Remember, the key points we covered are crucial for understanding the overall message and applying it effectively. I hope you found this presentation both informative and inspiring. If you have any questions or want to discuss further, please feel free to reach out. Once again, thank you for being here, and I look forward to connecting with you all in the future.